So, hello everybody, welcome back to ACE. In today's video, we're solving yet another real SAT math question from the official College Board Educator question bank. This one with question ID 02060533. I'll walk you through a step-by-step, break down the strategy behind the solution, and show you how to approach questions like this one with confidence each day. Okay, so here we're given a table of values where x is the input and g of x is the output. So for every x, we have the output g of x. So if x is equal to minus 27, and we put that in some sort of formula or algorithm, then our output will be g of x, which will be 3. Now here, the table shows 3 values of x and the corresponding values of g of x, where g of x is equal to f of x over x plus 3, and f is a linear function. What is the y-intercept of the graph of y equals f of x in the xy plane? Now you have to know that this x can also go into f of x. So since f of x is inside g of x, we're going to put the x in f of x. Now it's going to be f. So for the first one, as you can see, I'm just going to rearrange. So g of x is equal to f of x over x plus 3. So we have that. So putting minus 27, first value of x that we're given, inside f of x. So f minus 27 over x plus 3 equals 3. Now rearrange, times by x plus 3 on both sides. Both sides we're given f of minus 27 is equal to 3 in parentheses x plus 3. And then 3, and then in parentheses just expand again. So obviously here you've got the x, so here expanding with knowing that whatever is inside of the function you have. So sorry, here this 3 actually comes from g of x. So here if you noticed, g of x at the value of x is equal to minus 27, g of x is 3. So we replace g of x with 3. Then we just times by x plus 3 on both sides, and we put every x inside of the fraction f of minus 27, we replace it with a minus 27. So the x over here became minus 27. Then we just do simple math, and we get minus 72. Now that's one coordinate. Minus 27, so x is minus 27, and we're going to take it obviously here, because you know that y is equal to f of x. So we're taking y is equal to f of x. That is why minus 27 goes into f and not g. And then for minus 27, for f of x equal to minus 27, y is equal to minus 72. And then over here, we're doing the same thing, but now we're putting it minus 9 over x. So f of minus 9 over x plus 3 is equal to 0. Obviously here, I've just, substituted in the values that I've been given. Now, 0 times x plus 3, so timesing x plus 3 by both sides, I still have a 0. 0 times any number is a 0. So f of minus 9 is equal to 0. So now I've got my x-intercept, which does not matter. I just call it the x-intercept just like that. Minus 9 is 0. Now I've got two coordinates. I could create a line. I could create a straight line equation. I could find the gradient, and I could, by extension, find my y-intercept by using one of the values, by using one of the coordinates. So finding the gradient, rise over 1, so y2 minus 72 minus y1, 0, and then x2 minus 27 minus 9, so minus x1. This gives me 4. Just put into your calculator, I'll give you 4. Now y is equal to 4x plus c. Now we're trying to find c. So you could put in either value, either minus 9 0, so minus 9 as the x and 0 as the y, or you could put in minus 27 minus 72. So minus 27 as the x and minus 72 as the y. I chose the easier option, the one that would take me the less time. I could literally do that mentally. That's why I chose the easier option. So minus 9 0, put in the minus 9, that gives me minus 36 plus c is equal to 0. Adding 36 to both sides, I'm given to c is equal to 36. So 0, so whenever x is 0, so whenever x is 0, y is equal to 36. You have to know that the c over here is always the y-intercept in a straight line equation. Okay, well, that will be it. Obviously, the answer is a over here. So that will be it for today's video. Um, yeah, if you guys have any question or any misunderstanding about any of the topics in the SAT, whether it may be English or math, be sure to comment down below. Please do also leave a like and subscribe to support the channel. Yeah, we're trying to get to as many questions as possible throughout the summer period. And yeah, I'll catch you guys later and hope you guys have a wonderful day. Thank you very much.